Hello students, today we are going to learn about operators, and this is concerned with the assignment statements mostly. Let me first define what is an operator. Operator is a symbol that designates an operation. Let us take an example. Suppose we have got A equal to B plus C. Here the operator is the plus operator and the operation it designates is addition. Now, the operation of the addition in this case will be performed on B and C. Therefore, B and C are called operands, and the combination of operators and operands according to the rules of syntax is called the expression. Therefore, B plus C is an expression, and we have operands as B and C and the operator as plus. So, operator is a symbol that designates an operation. Now, what are the different types of operators available in C? There are three ways of classifying the operators. One is the classification based on function. Another is the classification based on the number of operands they act upon. And another is the classification that is based on the position where the operator is placed. Now, based on the function, we have got following type of operators. We have arithmetic operators. These operators are used to perform arithmetic operations. Then we have relational operators. These operators are used to perform the comparisons. Then we have got logical operators. These operators are used to combine the relational expressions and do the logical operations like AND, OR and NOT. Then we have bitwise operators. These operators are used to do operations at bit level. The first four and including the sixth one, these are, that is the increment and the decrement operator. These are responsible for data manipulations or calculations. Then we have another operator called assignment operator. This operator is used to assign the value to the variable. Like we have an equal to operator, that is the assignment operator here, that assigns the value of addition, that is B plus C, to the A. Now, assignment operator as such does not perform any calculation. It simply assigns the value that is in the RHS of the assignment statement to the variable that is present in the LHS. Now, we have got another operator, special operator called conditional operator, that we'll take later, and earlier I have also given example of this operator. Then we have certain special operators which are meant for special purposes, like star operator is there, dot operator is there, and size of operator is there, comma operator is there. We'll take them separately. But this classification is based on function. That is the type of function that is performed by the operator. Now, based on the number of operands that the operator can handle, we have three types of operators. One is nary, one is binary, and one is ternary. Nary operator can handle only one operand, while as binary operator can handle the two operands, and the ternary operator can handle three operands. We have only one ternary operator available in C, that is this conditional operator. Then based on the position, that is the place where the operator is being placed, we have got three types of what you call operators. One is the infix operator, the operator that is placed between the two operands. Like we have got plus operator that is placed between the two operands. We call such operator as a infix, because in means in between. If the operator is placed before the operands, then we call it prefix operator, and if it's placed after the operands, then we call it as a postfix operator. Most of the operators are what you call infix operators, that is arithmetic, relational, and logical, excepting one logical, that is not, that's a prefix operator. And you will know as we use different operators in our expressions whether the operator is a infix, prefix, or postfix, but this classification is mainly based on the position of the operator. Okay, next, once we use operators we can form expressions. Those expressions which are formed by using arithmetic operators are called as arithmetic expressions. Those expressions which are formed by using relational operators are called as relational expressions, and those expressions that are formed by combining the relational expressions using logical operators like and, or and not, they are called as logical expressions. Then we have got bitwise expressions. These expressions use bitwise operators only. Then we have got mixed expressions which can use variety of operators. Now arithmetic expressions specifically use arithmetic operators. Relational expressions specifically use relational operators, and no other operator is used in these expressions. Then logical expressions specifically use relational operators and logical operators, that is and, or, and not, to combine the relational expressions. Then bitwise expressions specifically use bitwise operators only to form the expressions. Mixed expressions can have all these operators combined according to the rules of syntax, and those expressions can be formed. Today I'll be focusing mainly on the arithmetic expressions. Now, arithmetic operators. As I told you, arithmetic operators are used to perform arithmetic operations. Like we have got addition. Addition operator is of two types. One that is used to perform addition, and one that designates a sign. Then we have got a subtraction operator, that is minus operator, that can be again used to change the sign of a variable or represent a sign of a constant. Such an operator is a nary operator, or it can be used to perform a subtraction between the two operands. Then in that case it's a binary operator. Examples will follow and you will understand what I mean by nary and binary, but I have already given the definition of nary and binary. Now division operator in C is represented by the slash, forward slash, and in math it is represented by this symbol, division symbol, but the function they perform is same. That is, if I write slash a slash b, it actually means a divided by b. That means I am dividing a by number b. Now multiplication in mathematics is represented by cross, but in C it is represented by a star. So therefore if I write a star b, it means a multiplied by b, same as mathematics. Then we have got another operator in C, that is the mod operator. This operator is used to obtain the remainder of the division. If I say a mod b, it means if a is divided by the b, what is the result of the, what is the remainder of the operation. Suppose if I divide 4 by 2, I know the remainder is 0. If I say now 4 mod 2, the result will be 0. But if I say 4 divided by 2, the result will be the quotient, that is the 2. So the difference between this mod operator and the slash operator is this, that the slash operator will give the result of the division, and this percentage symbol will give the result as the remainder. Okay, once you use them in the IDE, you can see the results yourself. Now examples of nary and binary operators. If I am using a is equal to l plus c, since plus is being operated on l and c, therefore plus is a binary plus. I am saying binary operator here, used as a binary operator because it is operating on two operands. Now if I say a is equal to plus b, it means plus is used on on a single operand, therefore it is a nary plus. Here it indicates the sign of the p, or it changes the sign of p. Now if I say a is equal to a minus b, Here the minus is a binary operator because it is subtracting the two numbers. It is acting on the two numbers, that is A and B. Now here this is an example of a nary minus where I have got a single minus before a operand, and that minus indicates the sign. Again, this is a binary subtraction. Now what is the difference between nary and binary subtraction operator, or nary and binary addition operator? The difference is based on the operands it acts upon. Since this operator, that is A is equal to minus 10, here minus is acting on a single operand, therefore it's nary minus, and this minus, since it's acting on the two operands, it is the binary minus. That is, this one will perform the subtraction, but this one will not perform the subtraction. It will indicate the sign or change the sign of a number or a variable. Okay. Now we have already discussed what are the expressions. As I told you, expression is a combination of operators and operands according to the rules of the syntax. Now what are arithmetic expressions? Arithmetic expressions are those expressions which use arithmetic operators to form the what you call expressions exclusively. Now before I go ahead with arithmetic expressions, I have to explain two things. That is, in the context of C, not in the context of mathematics. Now if I say constants, I have got two types of constants in C. One is the integer constant and one is the decimal constant. Now integer constant can be any number with a positive or negative sign, and decimal constant or a real constant is a constant which has got a decimal point. So if the constant does not have a decimal point, I cannot say that it is a decimal constant in C, even though a number, whether that has a decimal point or not a decimal point, that can be taken as a decimal constant in mathematics. But in C we have an integer constant, that is the number without a decimal point. It can be positive or a negative, and a decimal constant, that is the number with a decimal point. You should remember this. Now another thing is, that is, if I declare variables, they have their own data types. Now A, B and C are integer variables. L and P are float, that is they are actually real numbers, and K, R and J are double, that is they are the real numbers. Okay. Based on the type of operands, there are three types of arithmetic expressions. One is the integer arithmetic expressions. So arithmetic expressions are of three types. One is integer arithmetic expressions, another is the real arithmetic expressions, and third one is the mixed mode arithmetic expressions. What is the difference? The difference is the number is in the type of operands these expressions are having. Suppose an arithmetic expression is having all the operands of the type integer, then we say that the arithmetic expression is an integer arithmetic expression. Let us take these three expressions. Here we have got, now expression is always on the RHS side, that is of the assignment statement. That is, this side is the assignment side, expression side. Now 1 divided by 2. Let us see what is the type of 1. As I told you, when the numbers are without the decimal point, these are taken as integer constants. So this is an integer and 2 is also an integer. So both the operands are integer. So I say it is an integer arithmetic expression. Expression is said to be integer arithmetic expression if all the operands are integers. Now let us see this expression, that is b plus 5 divided by 2. 2 is an integer, 5 is an integer constant, and b is a variable of type integer because I have declared b as integer. Therefore this is a integer arithmetic expression. So in order to confirm whether the expression is an integer or not, you should check two things. First is the constants that are involved in the expression. If all the constants are integers constants, then the expression is integer. But there is one more thing that you have to check, that is the variables. These variables that are involved in the expressions should have a data type integer. So when both these conditions are met, that is when all the constants are integers and all the variables are integers in a particular arithmetic expression, then we say that particular expression is an integer arithmetic expression. Let us see the third example. Now in this example I have got two variables b and c, and I have a constant 3. That so far as the constants are concerned, that is 3, that is the integer constant because it is without a decimal point, and b and c both are integer variables. So I say this is an integer expression. For the real arithmetic expressions, I have to see all the constants should be decimal constants and all the variables should be of the type float or real. Now if you see this expression, that is L divided by O minus P star K, that is into K plus 2.4. If I see the constant, there is only one constant, that is 2.4, and this happens to be a decimal constant because it is with a decimal point. And now if I see variables K, P, O and L, that is K, that is of type double, and P, that is again of type float, and L, that is of type float, and this O you can take it as a float. I have forgotten to declare it. You can take this as a float. When all the variables will be of type float or double and all the constants will be integer constants, then we say the arithmetic expression is a real arithmetic expression. So how do we check whether the expression is a real arithmetic expression? The only check is that you have to check all the constants, and all the constants should be a decimal constants. Then you have to check all the variables, and all the variables should be of two types only, that is the floats or reals. Now in mixed mode arithmetic you can have combinations. See, in this expression we have got constants 1, 2 and 9.8. These two are integer constants and this is a decimal constant, that is 9.8 is a decimal constant. Therefore, since it does not have one type of constants, therefore we say it is a mixed mode arithmetic expression. I hope this is clear now. So an expression can be integer expression or a real arithmetic expression or mixed mode expression. If all the operands are of type integers, and then the expression is an integer arithmetic expression. If in a expression we have all the constants of the type decimal and we have all the variables either of the type float or double, then the expression is a real arithmetic expression. And in mixed mode expression, some of the variables can be integers and some can be float or double, and some constants can be integers and some can be some can be decimal. So I hope this is clear now. Next, what are data type limitations? Before I go ahead with the operators, I have to make this clear. Integer variables have got certain limitations. That is, the variables which have the data type integer have got certain limitations. What are the limitations? They can only hold the integers. If we try to assign decimal constants, or another name for decimal constants is real constants, or float or double data type variables in them, then truncation will take place. That is, the decimal part will be lost. Another important constraint which I have already discussed for these integers is overflow and underflow. That is, if you try to store larger values beyond its capacity, overflow will take, and if you try to store smaller values that is beyond its range, underflow will take place. What is the way out of that? We have to use modifiers or qualifiers. Let us go into IDE and I will explain the first point there practically now. Suppose I declare an integer variable int a, and I try to store in a 9 first, that is the integer. It can be positive or negative. Let me first store a positive value in it. Now let me store a negative value in it and let me watch it. And in this case there won't be any problem because the data type of a is integer. As I told you, the data type determines the type of operations and the type of values that can be stored in a. Let us today see it practically. We know now the type of values that can be stored in a are the numbers without a decimal point, that is integers, either positive or negative. Right now I have assigned two values to the a. Let us see whether it can hold it or not. Let me watch my A. What are the changes? Now, once the A has been created, it has got a junk value. Now, I have changed the value to A. That means it can hold positive values. Now, I have changed the value to -8. That means, again, that is changed. That means it can hold both positive and negative values. Okay. Now, let me try to put larger value in it. Larger. Suppose I put a very big number in it that is beyond its range, or I try to store a very big number that is beyond its range. The compiler will not give an error that you have stored something large in it. The compiler does not report this error, even though it should have. Let us now again run the program. Now see, there's a junk value in it. Now I am assigning a big number that is beyond the capacity of the A. What happens? This number is not retained in it. Something else has come into it. That means it has led to errors. Why? Because it cannot hold such number. It is only, integer is only 2 bytes, and there is a range of numbers that you can store. There is a limit to the largest positive number or smallest negative number that can be stored in A. And if you go beyond that capacity, it will lead to overflow in case of positive numbers and underflow in case of negative numbers. Now in the second case, I am trying to assign a very large negative number to A. What has happened? It has again, I don't get this number in A. So what has happened? There is called an underflow. But how do we overcome this overflow and underflow? There is a way by which I can increase the memory of A. That is, I can or change the sign of A if in case I have to store only positive numbers. For that we use modifiers. That I will take a separate lecture on it. But there is a way. But once you modify A, that is, you increase its size, and if you try to store something, some number that cannot be accommodated even in that size, again the overflow or underflow will take place because memory is limited. We cannot go for infinite memory in case of computers. So there is a stage where overflow and underflow will take place, but we can increase the range. That's what I want to tell. Now let me try to store some different type of data in A now. Now as I told you, A can hold only integers. Okay, that is, there was no problem in that, provided they were within the size of the A. They were within the capacity of the A. Once I gave those values, we had no problem in storing them in A. Let us now try to store something different in A. Let me store this decimal number in A and see what has happened as I execute the program. Now once I execute the program, watch what happens with A here in the watch window. First, A is given some chunk value. Now I am putting 9.88 into A, but A is an integer. It can hold only numbers without a decimal point. So what happens to the part that is after the decimal point? You see, that part is lost. Losing the decimal point part, that is the part of a number that follows after the decimal sign. This is called truncation. So if you try to assign a number which has got a decimal part, it will not be in a position to store that decimal part. That is the part after the decimal point. And whatever is the integer part, that will be stored, provided it is again within its capacity. Let me show you, 1 second. See here, again I try to store some other number in it, suppose 23.67. Now this number has got two parts. One is the first part, that is 23, and another part is that is after the point. We call this part 0.67 as decimal part, and we call this part, that is 23, as the integer part. Now if I assign this number to A, the integer part it can hold, but the decimal part it cannot hold. This memory location is not designed for that. This is the designer's limitation. The people who have designed C have made it like that, that it can store only numbers without a decimal point. So if you try to store a number with a decimal point in it, it will drop the decimal part and it will store the integer part. Dropping the decimal part or losing the decimal part is called truncation. Let us see. I'm trying to assign 9.88 into it. It cannot hold 0.88, it can hold only 9. So truncation has taken place. Now again A, it cannot hold 0.67 part of this number, it can hold 23 part. That's the first part, that is the integer part. Now see, so we made an important conclusion that is here. Integer variables can hold only integers, and if you assign decimal constants or real constants, that this we have done this part, or float or double type data type variables in them, truncation will take place. That is, the decimal part will be lost. Overflow and underflow I have also shown. Now I told you the way out of overflow and underflow is that we can use modifiers or qualifiers. Let me go to the second important point here. That is, if we try to assign those variables to them, that is, try to assign the contents of those variables to them which are of type float or double. See here. Now if I declare a variable of type float, as I told you, float and double can hold the decimal parts. If I declare a variable s and I say now s is equal to 1.2 or s is equal to 5.6, let us watch both these things. I am watching now s. Since s is a float, let us see whether it can hold it or not. Now see, after this statement, s is now holding 1.2. It has got the nature, it has got the capability to hold the decimal part of a number as well as integer part. So if I store 1.2 in s, since it's a float type, it can store the decimal numbers in it. But if I try to store this number in a, what will happen? It will lose the 0.2 part. Now if I again try to store 5.6 in s, the previous contents will be changed to 5.6. So s has the capacity to hold the decimal numbers, but a does not have. Truncation takes place. See, again truncation takes place. So I hope this part is clear. So s has the capacity, float variables and double variables have the capacity to hold the what you call decimal point numbers, but integer variables, they don't have the capacity, or they don't have the capability to store what you call numbers with a decimal point. Now let us try to do one more exercise and it will be clear. Suppose s is equal to 3.444. Now s can hold 3.444. Now I say a is equal to s. Observe here, s is of type float, therefore 3.44 it can hold. Now I am trying in the next statement assigning the value of s to a, but a is of type integer. Whatever is stored in s, will that be passed to a? No, only the integer part, that is 3, will be stored here, but 0.444 will be lost. See here. Now s, check here in the watch, it is 3.444 after this statement. The first value was the junk value. Now once I say a is equal to s, the initial value of the a is s, sorry, is junk because I have not initialized it. It is a junk value. Now once I assign it, you see what happened. S is 3.444, but a is 3. What is the reason? The reason is that because a does not have the capability to hold the decimal part. What it does, it accepts the integer part, but it throws off the decimal part. So once and for all times to come, you should remember now, integer variables can hold only integers, and if you try to assign decimal constants or float or double type variables into them and try to store their values in them, it will only accept the integer part and the decimal part will be thrown away, or the truncation will take place. I hope this is clear now. Now this is the data type limitation of the integers. Every data type has its own capabilities. It can, what is a data type? It's a property of a variable that can determine the type of values that can be stored in a variable and the type of operations that can be performed on a variable. It also defines the size of a variable. It also determines the range of the values that can be stored in a variable. So once I declare a variable in a declarative statement, that statement has lot of meaning. First I am giving the name to variable, then I am giving data type to the variable. Once I give data type to variable, it has got a lot of meaning, lot of information it is conveying. Okay, now we were actually discussing about the arithmetic expressions, but this part is related to that because we will be using the constants and the variables in our expressions. Now arithmetic expressions, we explain the operators, then arithmetic expressions, then data type limitations. Now evaluation of the arithmetic expressions. Once we write the arithmetic expressions like this, a is equal to b into c plus d, how will the operations take place? How we are going to predict the result? Can we know the result? There is one important constraint that is essential to be remembered so that we can understand how the arithmetic expressions are evaluated or the order in which the operations are being performed. That is, the constraint is that ALU can only do one operation at a time. Now if I have got an arithmetic expression like this, that is b into c plus d, this expression has got two operations, but ALU can perform only one operation at a time. So it will either do multiplication or addition. If it does multiplication, suppose, then after that it can do addition. If it does addition, then after it can do multiplication. Is it clear? So you should remember that the arithmetic logic unit, that is ALU, can only do one operation at a time. Or you can remember in C, if we write arithmetic expressions, only one operation will be performed at a particular point of time. And once that operation is done, if the arithmetic expression has other operations, after those only one operation will be performed, so on and so forth till all the operations have been performed and we get the final result. Now let us take an example of this. Suppose I have got expression like this, where I have got a is equal to b into c plus d. My expression is b into c plus d. Okay, now I assume that b has the value 2, that is my variable has the value 2, and c has the value 2, and d has the value 3. Okay, now this expression can be evaluated in two ways depending on the order in which the operations are being performed. We can either do multiplication first or we can do addition first. Let us first discuss if we do the multiplication first. This is the way one where we do the multiplication first. Here I have said a is equal to 2 into 2 plus 3, where I am using the values of these variables now, which I have already told what are the values. Now if I do multiplication first, 2 into 2 will be 4. Only one operation has been performed. Now what remains? That is the plus operation. Now after doing the plus operation, I get the result as 7. In case I start with multiplication first, then I go for addition, the result is 7. Now if I go for addition first, then in that case what I do, if I use a different order here, that is I first do 2 plus 3, I get 5, then I do multiplication, that is 5 into 2, here you should have a 10 here. Instead you will have an answer as 10 because 5 into 2 is 10. There is a typing mistake here. Now, so the result is different. In this case I am getting a result as 7, and if I do the operations in the reverse order, the result is 10. So which order should I adopt? That is my problem. In mathematics there is a way out. We have a BODMAS rule. That is, first we go for division, then we go for addition, so on and so forth. There's a rule, there's an order that is defined in the what you call mathematics, and you know the order. You have already learned in the preliminary classes of your schooling, that BODMAS rule. Now how does the C do it? As I told you, there are many things in C that are different from the arithmetic, and if the student has a pre-notion of the arithmetic concepts and he applies or she applies those concepts in the C programming, he's definitely going to get confused, even though those concepts will help him in understanding the C language. But in many cases, it will mislead him if he does not know the C's way of doing the things. When you will see further in the arithmetic expression the C's way of doing things, you will feel it is different from the mathematics. But you have to know that. Then only you can know how your program will behave, how your expression will be computed, and how will be the result generated. Now, if we have got many operators, how we know which operator will be what you call used first, that is which operation will be done first. As I showed you, if I do the operation of multiplication first, I get a different result, that is 7, and if I do the operation of addition first in the same expression, I am getting a different result, that is 10. So what do I do? How do I know what is the type of my result? If the computer does sometimes like this and sometimes like this, that is sometimes CPU does like this, sometimes CPU does like this, you don't know the result. You are not certain about the results, and it will lead to ambiguity. To remove this ambiguity, the C developers have designed a table. In that table, they give the order in which the operations will be performed. That is, they give the precedence to the operators. Precedence is a rule. Now, precedence, they give the precedence of the operator. Precedence is a rule that determines the order in which the operators will be used to perform the operations first. Now, that table is already given. That's an extensive table. I am here only showing the precedence of the arithmetic operators. But if you want to know it in your books, there will be a elaborate precedence table given that will list the precedence of all the operators that are available in C language. Now, that we will see later because we'll be needing that. Here now I am focusing on the arithmetic expressions, and in the arithmetic expressions, what is the rule? What is the order in which the what you call operations are performed? The rule is like this: the multiplication, division, and modulo division have the highest precedence. Highest precedence means they will be done first. That is, then after that, the second precedence is given to addition and subtraction. Now, if we have got multiplication and addition, multiplication will be done first. If we have got multiplication and division, now they have the same precedence. There is one more rule called as associativity that I'll be explaining in this lecture only after few moments. Now, we have seen the precedence determines which operator will be what you call used first. And if you write any expression using this table, you will know how your C language, that is the expression written in the C language, will be evaluated, or what is the order in which the operations will be performed. As I told you, and you must have understood it right now, only one operation is performed at a time. This is important rule. Only one operation. That means only one calculation is done, not two calculations, not three calculations, only one calculation. Now, as I told you, multiplication has a higher precedence than than addition and subtraction. Now, using this rule, using this table, let us see how this expression will be evaluated if I write it in a C program. If I write expression like this in a C program, as I know, multiplication has the highest precedence, rank 1. So this will be performed first. So 2 into 2 will be done first, that will be 4. Then what is left is the plus operation, that is to be done with 3. Now, since this is the only operation that is to be performed, so there is no problem with the precedence. We can carry ahead. We add 4 to the 3 and we get 7. So this is the order. This way will be followed by the C. This precedence method will be followed by the C, and whatever expressions you write, you have to use this table to evaluate those expressions. Then only you can do it manually, and the computer will also do it like that only. Otherwise you will not be in a position to know what will be the result. And if you don't know how the C will do the calculations, then you cannot check your logic, you cannot debug your errors. So you should know the order in which the operators are being acted upon, or the way in which the operations are being performed. And what is the rule that determines that? That rule is the precedence. And this is the rule that determines the order. Now, how we know the precedence? This is given in the table. You cannot change the precedence yourself. Multiplication has higher precedence than addition. Now, division, multiplication, and mod operator has the same precedence. This is labeled like this. You cannot change. This is given by the designer of the C language. Is this fixed way always useful? That is the predefined order in which the operations will be always taking place. It is always determined by the precedence table, and it is the precedence table that will be strictly followed by the C in evaluating the expressions. Suppose I have an expression like this: A is equal to B into C plus D, and now it was a fixed rule that B into C will be done first, then the addition. What was the reason? Because multiplication has a higher precedence than addition. But suppose my programming logic is like that, or my problem is like that, that I want to do addition instead of multiplication. I would have been always in a fix that, because I was dependent on the C. The C has provided the way out. C language has provided the way out. What is the way out? The way out is the parenthesis. That is, if I put the operator within the parenthesis, or any operation within the parenthesis, that operation will be done first, even if its precedence is lower. Now in this case, C plus D will be done first, and whatever result you get of that, that will be multiplied to the B. So this is the way how we come out of the precedence. We can break the precedence with the help of parentheses. Otherwise there would have been no other way to write the expressions, or the way we want it. Now, even if we have resolved the order of the operations, that is using the precedence table, there is still another type of the problem. Let us see here. If I say A is equal to C divided by 2 mod B, and C was 8 and B was 3, I can discuss it like this. Before this, I will have to go to the precedence table. Now in the precedence table, if you see, division and mod have the same precedence. That is, either division or mod, when they are in the same expression, either division can be done first or mod can be done first. Now if that was the case, what would have happened? Let us see. Now if you say C divided by 2 mod B, if you do the divide operation first, let us see the result, and if we do the mod operation first, let us see the result for the same expression. Now if I say 8 divided by 2, that is 4, and now one operation has been done, remains the mod operation. Then I say 4 mod 3. Mod always gives the result of what you called remainder of the division. So 4 when divided by 3, you get remainder of 1. And now here, if you see the other way around, that is where we do the mod first, which is shown in the red. Now if I say 2 divided by 3, or 2 mod 3, it's actually 2 mod 3, then what is the result? That the result is the remainder. If we divide 2 with 3, that is the remainder will be 2 itself. Now if I say 4 divided by 2, I get the result as 2. If I follow the path 1, the order 1, then I get the result as a 1. Then if I follow the order 2, I get the result as 2. What is the way out? Now this problem arises because we had two operators with the same precedence. In case I had two operators with a different precedence, I don't have any problem there, because the precedence table tells that the operator with the higher precedence will be used first. Now what will we do in this case when the two operators have the same precedence? The rule that is used there is called associativity, and it is again given in the precedence table. See, in the precedence table, one more rule is associativity. That is, if there are operators with the same precedence, if you see multiplication, division and modulo division, they have the same precedence. Now whether these operations will be carried from left to right or right to left, here the rule is left to right. So associativity is a rule that determines the order in which the operators of the same precedence will be, what you call, the order in which these operators of the same precedence will be operated upon. Okay, that is this rule is mostly left to right for most of the operators. And if you see the entire precedence table, this is not the entire precedence table. I have only shown the arithmetic operators here. And if you want to have a clear cut idea about all the operators that are available in C, their precedences and their associativities, you will find that in the complete precedence table. And you will see that 3 or 4 cases are where we have precedence from right to left instead of left to right. Now what is for the mod and multiplication and division, the associativity is from left to right. So let us see what happens in this case. In this case, now how we resolve the problem, we will not follow, we were in a fix whether if we follow this path we get a different result, and if we use this path we get a different result. What is the way out? The way out is associativity. What does the associativity tell? It is a rule which determines how the operators of the same precedence are applied. Two approaches as defined in the precedence table. You are not going to define this rule yourself. This rule is already defined, and you have to check the table again and again whenever you don't remember the precedence or associativity. Now in this case, the rules, two approaches are either left to right or right to left. Now in case of division and mod, as we have seen in the table, the approach is left to right. So the what will be done first, since these two operators have the same precedence, first what you call division will be done, and after that mod will be operated upon. So we know now the result by performing the operations in the associativity way, or in the rule that is given by the associativity. The result will be 1, and this result will be never computed. C will always do this expression this way. Now if I want the mod to be done first instead of slash, I could, if you remember, I told you we can break the precedence rule by using the parenthesis, but we cannot break the associativity rule. There is no way out of this. Only way out is that you have to reverse the order. That means you will have to write the expression in a different way. That is, instead of writing in this order, you can write B mod 2 divided by C, so that but you should write it in a correct order, so that the order is again correct. But there is no way to come out of the associativity rule. There is no way to break this rule, excepting that writing the same expression in the different order. Okay, so I hope, let me give another example of an expression which is a bigger one, so that it becomes clear. Now in this expression I have got variables B, C, L and G. I have given the values. Now which operation will be done first? Now I have got multiplication and division with the same precedence. Plus has got a lesser precedence, so I will be performing multiplications and division first. Now since these three have the same precedence, I will be going from left to right. How do I know that? In the table, because multiplication and division have the same precedence and their associativity is from left to right. Now the first 2 into 3 will be done. Okay, once this is computed as 6, then 1 into 8 will be done, and once this is computed as 8, then this division operation will be done, and remains the two additions. Again, these two additions have same precedence, so again the leftmost will be done first, then the rightmost, and I'll get the final result. Again we have used precedence and associativity to evaluate this arithmetic expression, to know the fixed answer, to know the fixed way that will be adopted by the C. And if this way was not known, we would have never told what kind of answers we would get in our expression. I hope you have enjoyed today's lecture. Thank you.